Right. So like you guys were saying, this thing we're going to teach today has really been used for thousands of years, and people are still going to use it. I mean, they use it all the time. People use it all the time. Does everybody use it all the time? No, of course not. Okay. I mean, you're not going to teach. There's not going to be one subject or one class that you're going to take that everybody does. Well, maybe English, they teach how to read, but still, a lot of people don't read, right? And but anyway, a lot of people use this. If it wasn't for this, this building would not be standing, all right? I mean, literally. It's so important. But they've known about this for thousands of years, okay? Thousands of years they've known about this. So I figure if it's lasted that long, I think it's important for us to know what it does. Wouldn't you agree? Yeah. It's got a weird name, Pythagorean Theorem. Okay, it's named after a guy. Anybody know? He is a philosopher. Pythagoras. All right? Yeah. You know how a long time ago a lot of people walked around, had one name, and that's all they had, right? You had Jesus, right? You had Peter, you had Paul, you had all those, David, right? Right. But Pythagoras was one of those guys. He was one of those guys. You know how Jesus had 12 disciples, right? That was not unusual in that day for a teacher to do that. They didn't have schools. They didn't have, ring the bell, all the kids come to a building and sit in school. That's not how they did school back then. Usually it was their parents would teach them, or somebody else, I guess, would teach them. But when you got older and you really wanted to get a higher education, you would follow somebody that knew a lot of stuff. Okay, usually these guys knew more than just one thing. This guy knew way more than just the Pythagorean theorem. All right, he knew philosophy. He probably knew music. He probably knew art. He probably knew, I know for a fact that he knew math and science and things like that. And so this guy would walk around and people would follow him. And he probably had disciples. I don't know if they called him disciples or not. I don't really know all the history about this at all. But Jesus was not uncommon to have, people following him around. Other people did. Have you heard of like Aristotle and Plato, names like that? Yeah, there's a bunch of people that did that. And this is one of those guys, okay? Where are you going? What? You couldn't go for all the nonsense we did earlier, and now you go right when I start teaching? Not good timing. All right, so let's talk about Pythagoras for just another second. He was Greek. A lot of those philosophers, a lot of the brain power in the world came from the Greek world. Don't know. It's just where it kind of concentrated. Somebody get the door, please. I'm not really sure why it was concentrated in Greece. What? How did they come up with it? That's a loaded question. It's not like one time one person came up with all the math. It's a progression. All right, started off really easy, Yeah, I mean, Adam and Eve, one apple and one apple. That was two apples, and that was the end of the world after that, right? All right, it wasn't an apple. It was a fruit, but everybody says apple all the time because it's a common fruit, but it probably was not an apple. But anyway, it's just a progression. It's not like one time something happened, and then we knew all our math, all right? It's just happened over time. Over time, people discovered things. In fact, the Pythagorean theorem was known way before Pythagoras. All right? So Pythagoras lived about 500 years before Christ. He lived from 570 to 495 BC, before Christ. Okay? That's when he lived. There you go. Yep. So, no, 25 years. Let's see. Oh, no, yeah. Yep, 85. So, so this guy knew about this theorem. They didn't call it the Pythagorean theorem when he was around. All right? I don't know what they called it, triangle theorem or something. I don't know. Who knows? I don't even know if they had a name for it, to tell you the truth. But the reason why it's called the Pythagorean theorem is not because he came up with the theorem. Okay, he was the first one to prove the theorem. Well, he probably was not the first one to prove the theorem, but he's the one that's credited with giving the best proof to this theorem at that time. All right, we'll say it that way. All right, so he proved this theorem. Now, we are not going to prove it in here. I have it in my notes. We probably could. There's a bunch of different proofs. I have probably one of the most simple proofs for this theorem. If you're really interested in seeing the proof, you could always go to my honors geometry class, go to section 7.3, Pythagorean theorem, and scroll to where you see the proof. All right, it's probably early on in the video. All right, but Pythagoras is the first. He's the one that's credited with proving the theorem. We'll call it that. Okay. In fact, there's a lot of different proofs of this. A lot of different ways to prove it. Some are a lot more complicated. Some are a little easier. In fact, maybe on Wednesday, I might show you a video of these two girls, two high school girls, and they're from a Catholic school somewhere down south, like in Louisiana, I think, or something like that. And they actually came up with a different proof that nobody ever thought of before to the Pythagorean theorem. And it's pretty ingenious. I don't understand it all, and these are high school girls, okay? And it's pretty incredible. They made the news, they got real famous, and it was just, I think, just a few years ago. I don't think it was that long ago at all, where they came up with a brand new proof to the Pythagorean theorem, all right? But Pythagoras is credited with proving it. Again, I'm almost positive they did not give him credit and call it the Pythagorean theorem when he was alive. I think it was a long time after. Again, I'm not a history buff on the math stuff. You could always look it up. You got Google right at your fingertips if you wanted to see that. YouTube, there's tons of videos about the Pythagorean theorem. There's tons of videos about Pythagoras himself. Feel free to look it up. All right? No, he did a lot of stuff. Like I said, he was a philosopher. He was a teacher, right? Well, it's the biggest thing that I know that he's known for. He's probably known for a lot of other things. You can look him up, okay? Just Google him, and you'll probably find a lot of stuff that he was instrumental in. All right, enough of that. Enough history. Wasn't much history, but it's a little bit. So let's talk about the Pythagorean theorem. First of all, here's the key thing that you got to know. The Pythagorean theorem can only be used with right triangles. Okay? Write that down. You can only use Pythagorean theorem with right triangles. All right? So let's draw a right triangle. How about that? All right, there's Pythagorean theorem, or there's the triangle, sorry. There's a couple things we got to know before we actually show you the Pythagorean theorem. And this is probably something you've heard before. I doubt it. I really, really doubt this is the first time you've heard of Pythagorean theorem. Would you agree with that? Have you at least heard the name before? Yes. Okay, yeah, you probably heard it before. Okay, whether or not you know how to use it or what it is, it might be a different story, but I'm sure you've at least heard of it. This is a common thing that they would teach in Algebra 1, all right? It's a very, very common thing that you would see in Algebra 1. I don't know if before Algebra 1 they teach us. I don't know. I'd have to ask some middle school teachers if they teach Pythagorean theorem. And I just don't know. So what we're going to do is we're going to label these three sides. We've labeled them before. I almost said the most important side. I don't know if there is a most important side, but the one that stands out the most probably is this side right here. What name do we give this side right here? It's the hypotenuse. Good. And we have talked about that this year, haven't we? Yeah, because we've talked about right triangles. We've talked about the names of the three sides of the right triangles. So that is the hypotenuse. So if we call this the hypotenuse, what do we call this side over here? It's a leg. All right? And that's a leg as well. All right? Now, they could be different sizes or different lengths. That's fine. All right? But they are still called the legs. How do we know that this one is the hypotenuse and not this one? Okay, it's not just because it's the longest side, because you could have a triangle. I did this in the last class. Watch this. Well, let me get that to meet up. That's close enough. Look at this. See the side right here? That's the longest. Do I call that the hypotenuse? Nope, it could not be. This absolutely could not be the hypotenuse. That's it. This doesn't have a right angle. So where is the hypotenuse in reference to? It's opposite the right angle. That's exactly right. You see that? So the hypotenuse is always opposite the right angle. Okay? Why is it the longest side? Just because I said it was? Because on a right triangle, this 90 degree is always your largest angle. Here's again something we've talked about earlier in the year. We said that the side opposite the biggest angle is always going to be the biggest side. Same thing here. If this is an obtuse triangle, that's going to be your biggest angle, so that's going to be your longest side. But does that mean that this is the hypotenuse? No. The hypotenuse is only opposite what? The right angle. Everybody see that? All right, so that's why that's the hypotenuse. Okay, enough of that. Whoops. What did I just do? There we go. Let's go to a different color. What we do, we haven't even shown you the Pythagorean theorem yet. We're going to in a second, but let's do this. The hypotenuse, we're always going to use the letter C for the hypotenuse. The two legs, we're going to use A and B. All right, so A, B, C. Everybody got that? C always refers to the hypotenuse. So let me write down what the Pythagorean theorem is, and then we're going to do a bunch of examples on how to find missing sides. That's what we do a lot in here, isn't it? We find missing sides, missing angles, solve for x, all that kind of stuff. That's what we're going to do. Let's do this. So I tell people the Pythagorean theorem, let's write it down again so that we have it all together. Pythagorean theorem. I tell people it's easy as ABC. Why do I say it's as easy as ABC? Because it's a squared plus what? B squared equals C squared. See? I knew you learned this at some point. All right? So there it is right there. That's super important. That's one of the... I told my last class, I said, I think this is probably the most famous formula or theorem that there is. All right? As far as high school kids anyway. All right? I think that's the most famous theorem that there is. Probably in all of math. If I go out on a limb, I'd probably say that was true. So what does that mean? What does it mean, first of all? What's that stuff? What are these little twos right here? They're squares. What do I do when I square something? Good. Times it by itself. Very good. All right, so let's do one. Again, what kind of triangles can we only use? Right triangles. So I'm going to draw a right triangle. Maybe. There we go. That's better. And what we're going to do is we're going to put some numbers in here, and you're going to solve. I'm going to give you two sides. You're going to find the missing side. Again, it's got to be a right triangle. I'm going to start off very, very easy. It's probably one of the easier ones that you'll ever do. So let's say that side is 3. Let's say that this side is 4, and I want to find this side right here. All right, we'll call it C. All right, so let's put it into the Pythagorean theorem. So the a squared, and it doesn't matter which one's first. It doesn't matter if you call that A or B. It doesn't matter that you call this A or B. This is always the hypotenuse, so this one is always got to be the one that's by itself. Okay, you only take the legs, square them, and add them up, okay? Don't ever square this one, and add those two together. Everybody see that? You'll only add up, after you square them, you'll only add up the legs, and that always equals the hypotenuse squared. In fact, in you know the movie Wizard of Oz and the Scarecrow, when he gets a brain, right? Is he the one that gets the brain? Or the Tin Man? No, yeah. The Scarecrow gets the brain. So he gets the brain from the wizard or whatever, and he rattles off this thing that's supposed to sound really smart. And what he's reciting is the Pythagorean theorem. And if you listen very carefully, he doesn't say it exactly right. It's pretty close, but it's not exactly right. If you go, I'm not going to do it because of time, but if you go on YouTube and put, what's the name of that movie? Wizard of Oz, Pythagorean theorem, all right, you'll see that he rattles off the Pythagorean theorem, but it's not quite right. But he says something like this. He says, the square of the hypotenuse is equal to the sum of the squares of the other two legs. All right? And that's what the Pythagorean theorem is. And that's what he says on the Wizard of Oz, which is kind of interesting. All right, so let's do this. A squared plus B squared. So what do you want to call the A? The 3, and then the B is the 4, and then, of course, that's the C. So let's write it out before we do it in our head, okay? So we go what? 3 squared plus 4 squared equals c squared, because we don't know what that is, do we? So I put a c. Let's do the math. 3 squared is 9, because it's 3 times 3. 4 squared is 16, because it's 4 times 4, equals c squared. 9 plus 16 is 25. That equals c squared. Does that mean that this length is 25? No. Okay. If I take a number and multiply it by itself, and it equals 25, what is that number? What number times itself is 25? 5. And that's what we're doing. So here's what we're going to do. We've got to get rid of that square. How do I get rid of something? I always do the opposite. So the opposite of squaring something is taking the square root of something. So I take the square root of this side and the square root of this side. And what the question I asked just a few seconds ago, what number times itself is equal to 25? That's what the square root means. Everybody understand that? So when you see the square root of something, what does that tell you? It tells you what number times itself, right? The same two numbers multiplied together is going to equal 25. It's 5, isn't it? So what's c equal to? C is 5. And there you go. So c is equal to 5. Everybody with me on that? So you've done your first Pythagorean theorem, at least in here. Again, you've probably done this other places, but let's get rid of all this. Now watch. Instead of doing all that, we have these things called Pythagorean triples. I hope you're watching. We're not finished this. What I'm doing right here can really help you out instead of doing all that math. I erased it, but instead of doing all that stuff, you should be able to look at this, that being 3 and that being 4, and knowing automatically that that's a 5. And that's called a Pythagorean triple. Triple because there's 3 sides, there's 3 numbers, and all 3 of these numbers are whole numbers. They're not decimals. If I take the square root of it, I took the square root of 25, right? It came out to a nice whole number. So here's my Pythagorean triples. The first one, you just put them in order from the smallest to the biggest. So we call this a 3, 4, 5 triangle. Okay? Or you could put right triangle. All right? But when you see 3, 4, 5, you automatically know it's a right triangle. So you guys are going to pretty soon be taking that PSAT. I remember I used to teach a couple classes years and years ago, SAT prep and all that. And there was a lot of problems where knowing your Pythagorean triples really helps you out a little bit. All right? You could still solve the problem without knowing your Pythagorean triples, but knowing them just makes things go a lot faster, a lot easier. So here's the deal. Knowing that if you have a right triangle and you got your 2 legs as 3 and 4, automatically, what's that hypotenuse going to be? It's going to be 5. Okay? What if you had this? What if they told you the hypotenuse was 5, but they didn't tell you one of the legs? Now, you could do the Pythagorean theorem. Let's do it, just for fun. All right? Let's say we didn't know what A was. All right? And you didn't know anything about a 3, 4, 5 triangle. All right? So how would you do this? How would you solve for A? Well, you'd use the Pythagorean theorem. So I go a squared plus what? 4 squared equals, now we know that one, that's 5 squared. So what's the math? A squared plus what? B squared. Well, I already did the b squared. What's the 4 squared? It's 16. You're a step behind. Equals 25. Now what do? Subtract a 16 from both sides. So a squared equals, what's that? 9. Take the square root of both sides. And what's a equal to? 3. You could go through all this mess right here. But knowing your Pythagorean triples, you could look at this and say, this is something for 5. It's a right triangle. 5 is hypotenuse. What is that something? Something for 5. What is it? It's 3, 4, 5. Do you see it? So knowing your Pythagorean triples, you didn't have to go through all this, did you? I mean, you could have. It still works. Okay, but you didn't have to. So the Pythagorean triples just makes life easier for you, where sometimes you can just look at it and say, oh, that's 3, or oh, that's 4, or oh, that's 5. Okay? So again, what if you had this? What if they didn't tell you what B was, but they told you A and they told you C? Without going through this whole mess right here, what would B be equal to? It's 3 blank 5. What is it? 3, 4, 5. Okay? Does it make sense? What if they did this? Now, I'm really going to make you think a little bit. So don't just throw out stuff. What if I said B was 5 and I asked you to solve for C? Is that a 3, 4, 5 triangle? Is there a 3, 5, 6 triangle? Well, you could always look to see, couldn't you? Since you brought that up, let's do it. Is there a 3, 5, 6 triangle? So 3 squared plus, would you say 3, 5, 6? Plus 5 squared. Let's see what that's equal to. Let's see if it is. C is equal to 6. What's that? 9 plus what's that? 25 equals C squared. 9 plus 25 is what? 34 equals C squared. Square root both sides. Now look, what's C equal to? It will be a decimal. Do you know what it's close to? I want you to think about square roots a second. 34 is really close to what that you can take the square root of? 36, because I can take the square root of 36, can't I? So what is the square root of 36? Right, the square root of 36 is 6. So take a wild guess. It's not a wild guess, it's an educated guess. Where do you think the square root of 34 is? Approximately. Okay, but it's not 34 and a half. The square root of 34, watch. The square root of 36 is 6. Okay, so the square root of 34 is just a little bit smaller than what? The square root of 36. So this is a little bit smaller than 6. So you think it's that much smaller? It's got to be bigger than 5, because what's the square root of 25? It's 5. So this is bigger, listen, this is bigger than 25, isn't it? So you know it's bigger than 5, but you know it's also less than 6. But it's a lot closer to 6. It's probably, it would be my guess, somewhere around 5.8. Let's see. It could be 5.9. Let's get my calculator out. So 34 square root, 5.83. So it's about 5.8. Does that make sense? What the square root of 34 is? Yeah, it's a little less than the square root of 36, which we know is 6. So 5.8 sure is a little less. So this is approximately what? 5.8. So is that a Pythagorean triple? It's not. Now you said 3, 5, 6. You were close, but is this 6? It's not. All right, so there is no 3, 5, 6. Now, there are some other ones. Let me show you some other ones because we're pushing our time here. Let's get rid of that thing. There are some other Pythagorean triples. All right, here's another one. 5, 12, 13. Now remember, these are all whole numbers. There are rarely any right triangles when all three sides are all whole numbers. Most of the time, you're going to have decimals or square roots, okay? Everybody with me? All right, if I give you two whole numbers, the third side most of the time is going to be a square root of something that doesn't come out even, which means it's going to be a decimal. So 5, 12, 13 is one of my Pythagorean triples. Another one would be 8, 15, 17. And another one is 7, 24, 25. I would just memorize these, all right? Those right there can really save you a lot of work if you can remember them, all right? That's the key, all right? 5, 12, 13, 8, 15, 17, 7, 24, 25. So what does that mean? Let's do the 5, 12, 13. That means, forget these, okay? Let's just get rid of it, make it a little cleaner. All right, so what if I said that this was 5 and this was 12? Instead of doing the whole Pythagorean theorem, you're like, oh, it's a right triangle. I got a 5 and a 12. The hypotenuse must be what? 13. Okay? What if this was 8 and that was 15? What would this be? 17. What if that was 7 and that was 24? What would this be? It'd be 25. You see that? So these are special. All right? You don't see them a lot. That's why there's only a handful of them here. There's more than this, but it's impossible to remember all of those, okay? So this is all we give right now. But there are more than these, but it's kind of rare that this happens. So what if I gave this? What if I said find x or solve for x? What would it be? What is it?
5.
It's just 5. That's it. You don't have to do any math. Correct? You just look at it. Blank 12, 13. Oh, that's 5, 12, 13. All right, I got it. Make sense? All right, let's do another one of these Pythagorean triples. What if I said that this was 7 and this was 25 and I asked you to solve for x? It's 24. How did you know? Because you used your Pythagorean triple. What if you didn't believe me? What could you do to prove that that was true? Well, let's do it. X squared plus what? 7 squared should equal what? 25 squared. All right? So this is x squared plus 7 squared is 49 equals, I don't know. I should know that. 7, what? No, it's not. 625. That's a number I should know, but I forgot. All right? Everybody see what I just did? I went this squared plus this squared should equal this squared. All right? Right there. Subtract 49 from both sides. So minus 49, that's 576. So, oh, come on, x squared equals 576. Take the square root of both sides. So what do I do in my calculator? Hit square root. Sure enough, x equals 24. But did I have to go through all this mess? Didn't have to, all right, if I knew my Pythagorean triples. If I knew 7, 24, 25, I could have just plunked it in right there, and I would have been good. Does that make sense? All right, so the Pythagorean triples can come in really, really helpful. Since we're talking Pythagorean triples, I think I've done enough with the other stuff. Oh, let's do this. Let's get rid of this.
What's the hardest theorem you had?
I don't know. I have no idea what the hardest theorem I've ever seen. I probably wouldn't remember it if it was that hard. I probably wouldn't remember it anyway. So, all right, watch this. This will be the last thing we do today. What if I said that this was 15 and 20, and I asked you to solve for x right there? I could go 15 squared plus 20 squared equals x squared, right? Add them up, take the square root. I could do that. That's fine. But this is actually a Pythagorean triple. You're like, Mr. Hamrick, no, it's not. It's not on my list. I don't have a 15 or a 20. But I do have something that goes evenly into this. What divides evenly into 15 and 20? A 5 does. 5 goes into 15 how many times? 3 times. Into 20 how many times? So really, I do have a 3, 4, what? 5 triangle, but is x actually 5? No, because this triangle is actually 5 times bigger than a 3, 4, 5. Okay? So watch. How did I get to 15 from 3? I went 3 times 5. I went 4 times 5. So I go 5 times, which is 25. So this technically is a 3, 4, 5 triangle. Would you agree? So instead of doing that whole 15 squared plus 20 squared equals x squared, you could have done that. That would have been fine. You got a calculator. Couldn't be that hard, right? You could do it that way, or you could look at it and say, oh, wait a minute. That's a Pythagorean triple. That goes into it 5 times, 3, 4, 5. Multiply it by 5, 25, and I'm good to go. Make sense? All right. So do you have to know these? No, you don't have to. It makes life a lot easier, though, if you do. So your homework is section 7.3. We're going to call it A. We're going to break this up into 2 parts, and it's numbers 1 through 10. It's not too bad. So look for those Pythagorean triples if they show up. They don't always show up, all right? Not every triangle is going to have a Pythagorean triple, all right? If it comes out to a square root, like this one right here, it came out to a square root of 34, just keep it. Everybody watch. You're not watching. If your answer comes out to a square root and it doesn't come out even, just leave it the square root of 34. You do not have to put it into a calculator and get a decimal number. Okay? So let's do that. If it comes out to a weird square root, then you just leave it, that weird square root. And then that's good. That's good enough. I'm happy with that. All right. Get that homework done. And that will be due tomorrow.